Okay, so we are going to start with the discussion of physical properties of the ionic compound. Okay, so move to the slide number 2. So if we talk about the physical properties of the ionic compound, so even we have discussed about this one in the previous lesson. So can you tell me that what are the major properties of the ionic compound? The first one, did you remember it? Your mic is muted. Okay, so if we talk about the physical properties, the first one physical property of the ionic compound that we have discussed in the previous lesson, it was that they exist as crystalline solid. So the first and most important property of the ionic compound is that they exist as the ionic they exist as the crystalline solid. So if we talk about the crystalline solid, I have told you a term that we even discussed in the previous lesson. It was the crystal lattice. So can you tell me that what do you know about the term crystal lattice?
Um, the crystal lattice is like
Yeah.
um, it's a repeating arrangement
Yeah, very good,
of
very good. So crystal lattice is basically a structure that is basically formed by the repeating and regular arrangement of the particles in the three-dimensional space. So we can say that repeating and regular arrangement of ions, because if we talk about the ionic compounds, so in the case of ionic compound the particles are ions. So just like you can see that a structure is presented on the slide, so basically this type of structure is called as the crystal lattice. Here you can see that the positive and negative charges, or the positive and the negative ions, they have a specific arrangement, and that arrangement is repeated throughout this structure, and this structure is present in the three dimensions. We have discussed about it, that whenever a structure or a body is present along the x-axis, y-axis, z-axis, so that is basically called as the three-dimensional arrangement of the particles. Okay, so the first one point is clear, that the ionic compounds exist as the solids, and they are not the ordinary solids, rather they exist in the form of the crystalline solids. And basically the crystalline solids are those compounds, or you can say that those solids which have a regular arrangement of their particles, right? So move to the next one slide. The next property of the ionic compounds that is discussed is that about their melting end point. So we can say that they have high melting and boiling points and boiling points. So even we have discussed about this one point in the previous lesson, that the ionic compounds have high melting and boiling point. So can you tell me that why their melting and boiling points are high? Do you know the reason for this one? Aniba, can you tell me the reason for this one? That why they have the high melting and boiling points?
Sorry, I forgot I was muted. It's because of uh their electrostatic force.
Very good, excellent. So it is because of
Electro-
strong electrostatic forces. Yeah, very good. So because of strong electrostatic forces, because we have discussed that if we talk about the ionic bond, so ionic bond is an electrostatic force of attraction between the oppositely charged ion, and these electrostatic forces of attraction, or you can say that the interaction, they are very strong. And because of strong electrostatic force between the ions, it is very difficult to separate the ions from each other. And you know that when we have to melt a solid, or when we have to boil anything, we have to separate the ions, and we have to supply a lot of energy, we have to supply a lot of heat to separate the ions. So that's why the melting and boiling points of the ionic compounds are very high. So I gave you the example that if you talk about the NaCl, so the melting point of NaCl is very high. It is almost near to the 800 degrees centigrade. So it means that a lot of heat is required to separate the sodium and the chloride ion. Okay, the next property that we are going to discuss is about their solubility. So we have seen that the ionic compounds are soluble in water. Just like we can see that if we add a small amount of NaCl in a glass of water, it would easily dissolve. So we can say that the ionic compounds are soluble in water but insoluble in organic solvents. Okay, so if we talk about the water, so water is a polar compound and it can easily interact with the charges that are present in the ions. So that's why the ionic compounds become soluble in water. So we can say that why it is soluble in water. So the reason for this property is that water is attracted towards ion. But if we try to add a small amount of NaCl in the mustard oil, so what do you think? If we add if we add sodium chloride in the mustard oil, would it will be soluble or not?
No.
No, it would not be soluble, because if we talk about the mustard oil, so mustard oil is an organic compound, that is a non-polar compound, and it would not dissolve the NaCl. But if we talk about the water, so water is an inorganic compound, it is a polar solvent, and it would easily dissolve the ionic compound, it would easily dissolve the sodium chloride. Okay, very good. The next property we can talk about is that they are bad conductors of electricity, electricity as solid, but good conductors as aqueous solution. So if we talk about the ionic compounds, so they are bad conductors of electricity when they are in the solid state. Move to the next one slide. Okay, so basically if we talk about that why they are bad conductors of electricity, so can you tell me that when the electricity flows, so what is the process involved in the flow of electricity? Can you tell me about that?
The electrons flow.
Yeah, so keep in mind that whenever or wherever there is the flow of electricity, the electricity always flows when there is the movement of charge. So we can say that the electricity or the electric current is actually the flow of charge. The charge can be the electron, or the charges can be the cation and the anion in the case of ionic compound. So when we say that the ionic compounds are the bad conductors of electricity when they are solid, so can you tell me that why they are bad conductors of electricity in the solid state?
Because the electrons do not flow.
Yeah, so keep in mind that in the case of ionic compounds, we would not talk about the electrons because electrons are not present in the isolated form. In case of ionic compounds, we have the positive and the negative ions, the cation and the anion. So if we talk about, so we can take the example of the NaCl. So suppose we are talking about the NaCl, so we can take the example of a beaker. Suppose we have this beaker where we have the crystals of the, we can draw the crystals. Suppose this is a crystal of sodium and the chloride. So this is chloride ion and we have the sodium ion. So if we try to pass the electricity with the help of, you can say that we put two electrodes here and we connect them with a battery, positive, negative. But the problem is that there is no flow of current between the two electrodes. Why? Because the Na plus and the Cl minus ion, they are tightly bounded with each other. They cannot move. So that's why there is no flow of charges, so no current is produced. So we can say that as solid, charges are not free to move. So when you have an ionic compound in the solid state, the charges are not free to move. As you can see on the slide that sodium ion is tightly attracted with the chloride ion. So the charges or the ions, they cannot move, they cannot flow. So that's why the ionic compounds are bad conductors of electricity in the solid state. But suppose what we do, we add water in it. Okay, so when we added water, we have seen at the previous slide that the sodium chloride and all ionic compounds, they are soluble in water. So suppose what happens, the chloride ion separates from the sodium ion. Now we have the chloride ion here, separated from the sodium ion. Okay, so now we have this electrode attached with the positive terminal, so this is positive and this is negative. Okay, so can you tell me that now whether the charges would move or not in the form of solution, whether they would move or they would not move?
They would move.
Okay, very good, they would move. Okay, so if we talk about the sodium ion, whether it would go toward the positive terminal or it would go toward the negative terminal, what do you think?
They would go to the negative.
Negative terminal, very good, because itself it is positive ion and it would prefer to flow toward the negative terminal. Okay, so it means that it would move toward the negative terminal. Very good. So whenever the charge has moved, so it means there has been created some current, right? Okay, so if we talk about the chloride ion, toward which electrode it would go, positive or negative?
Positive.
Positive, because itself it is negative and it would prefer to move toward the positive terminal, so we can say that it would go toward here. And when both the positive and the negative ions they are moving, so it means that current is produced. So now we are going to talk about the second one thing, that why they are conductors of electricity in the form of solution. So we can say that in aqueous solution, ions are free to move. So when the ions are free to move, so it means that the aqueous solution of ionic compound or aqueous solution of a salt is conductor of electricity, and this is what we have seen. So we can say that these are the four major physical properties of the ionic compounds. Did you get it? Whenever you are muted, have you got it?
Yeah.
Okay,
Yeah, I got it.
very good, excellent. Okay, so we are going to start with the discussion of physical properties of the ionic compound. Okay, so move to the slide number 2. So if we talk about the physical properties of the ionic compound, so even we have discussed about this one in the previous lesson. So can you tell me